Yo, yo, yo! What's up, everybody? Welcome back. Today we are working on rendering fonts from scratch. And today's topic is actually doing the rendering. Yesterday we opened up a TTF file. I think in here somewhere. And we got to the point where we could kind of like parse the overall structure of this thing. And if we run what we made, we are running it on our go-to TTF file hack, and we are just trying to see what do we get if we look inside. So we have found the glyph definitions for each letter, right? And we have some sort of reasonable proof that these are sane, right? So we were kind of thrown off at the end of stream yesterday because we ended up calculating that like the glyph index is like 1400, but B and onwards are like kind of like low numbers, which doesn't really make sense. But off stream, I did manage to look at the number of contours associated with each thing. I cheated a little bit. I did a little bit of off stream work, which I don't like doing. But if we look at the TTF spec, in here we go to the glyph table. All I did was take the information we already had and literally just say the first thing in the glyph data is the number of contours. So all I did was cast the number we already had to a uint16 or an int16 and just look at what we get. So we see that A has 2 contours, B has 3 contours, C has 1 contour, D has 2 contours. And these are starting to look like very sane. One, we can kind of see that like the byte offsets are kind of like monotonically increasing to some extent. And if we actually were to try to draw these letters, we'd get the same amount of contours as we are getting here. So we have some like reasonable proof that we have found the glyphs in the font. So like just to prove it, like A has 2 contours. If you were to draw an A, you could kind of like draw the outline in kind of like 1 stroke for this, 2 strokes for that, right? B, you would kind of draw like something like this, and then 2, 3, right? Those are your 3 contours, and so that like lines up here. C, you could draw in 1, right? You go C, right? And I kind of like eyeballed this going down the list. I'm like, okay, these are probably sane. So what did we learn yesterday? Overall structure of a font file. You open up this thing, and off rip, you just start getting like this, like there's like this offset table, and this offset table kind of tells you what. Let's see if we can remember. Offset table tells you this stuff: how many tables there are, and a bunch of stuff that we haven't really looked at yet. Then each table has this like table directory entry, which says like I am a table of this type. Here's my checksum. Here's where I am in the file, essentially. And then we have looked at a few of the tables that are kind of like supposedly in any font file, but at the very least they're in this file. So we kind of found, we are looking at the head table, max p table, cmap table, locate table, and glyph table. The important thing here is basically these guys are kind of like metadata for the whole file. So head is kind of just like a header for the whole file. The max p table we needed to look at to find out how many glyphs there were in the font. The definitions of these things are like kind of just constant, right? So the head table is just this stuff. So like font revision, version, flags, how big we expect stuff to be, stuff like that. Max p table, the only thing we really looked at here was num glyphs. And then we got into the kind of like harder stuff, which is the cmap table, which is a list of kind of character, we can call it character map, like which glyph is associated with each character, essentially, I think. And this was kind of like difficult for us to parse. There are a lot of like different versions of this thing. Our font is using this like format inside called subtable 4. So I think we do something like we look at the platform ID of this thing. We then say if there like are going to be several character tables depending on if you're like on Windows, on Linux, using Unicode, like 16-byte integer characters or 16-bit integer characters, whatever. So we say, okay, our thing has Unicode BMP maps, and then when you jump to the thing, you say, oh, this subtable has like some format. There are many formats. We've only looked at format 4, and where you can like extract essentially a index for a glyph based off a character code that follows some sort of like non-trivial logic to get there. But we've guaranteed that that's correct. And so all we're doing now is we just say, give me my TTF. Let's look at the CMap section. Let's try to figure out what the fuck is in there. And if it is what we expect it to be, let's look at the location table, which will tell us where in the glyph table the definition of the glyph is. and then we are there, right? So today we are starting with trying to actually render some glyph data. And we do not know what that's going to be like yet. I have looked at this page in advance. And basically, the expectation here is that every segment of a character is going to be made up of a cubic or quadratic Bezier curve. Right, so you can define a Bezier curve with 3 points. There's a really good visualization on Wikipedia, I think, for this. But a Bezier curve is essentially you take some points and you interpolate between them. Here, this picture says all you gotta know, right? So you take 3 points, you basically like slowly walk up these lines at like the same rate. So like at 0.5 in, you're going to be like 0.5 between 0.0 and 0.1, as well as 0.5 between 0.2 and 1.2. You draw a line between those, and then you interpolate with the same time step between in that new line, and that's how you draw a Bezier curve. So they're kind of saying, we're going to have Bezier curves defined this way, but we might get a little tricky and say, if I'm drawing, like, if I've got like a bunch of points stacked up, it might make sense for me to kind of implicitly define like a point based off 2 other points. I haven't really looked too closely at this yet. I assume that we will come to this naturally. So we're expecting our glyphs, I guess, to have a series of points that will define some contours. That is what we are going to be looking at. So I guess the important thing to do is to start trying to look at the glyph data representation and figure out what the fuck is going on. Okay. So yeah, what we've parsed right now is just this number of contours number. That's literally the only thing, I think. I see, yeah, num contours is like, I just call like I16 on the glyph data at this place. We have glyph start. I guess we need to find the glyph end as well, which I think we saw yesterday was in the location table at glyph index +1. I'm pretty sure that's what we saw. And let's try just trying to find out what's going on there. So we are expecting the glyph description to have these things up front. We've looked at number of contours, but then we are also expecting to see these things. What is like an F word? What is an F word? Here is what I want. F word, 16-bit signed integer that describes a quantity in F units, the smallest measurable distance in EM space. Okay, so we can just write I16 there, I guess. That's fine. So we are going to have basically this definition, and then we are going to have to determine if we are a simple glyph or a compound glyph. And I think that we're lucky in that every single glyph I've seen so far is a simple glyph, so we can probably just skip. I know the F word. Genius. This guy's a fucking genius over here. So can we look at like maybe here? Maybe we store it here. So here we're gonna have like glyph common. And it's gonna be a packed struct. And he's gonna have this stuff in it. Anything that says F word is I16. Okay, this is an I16, number of contours, this stuff is garbage, 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 okay, and then we're gonna do a little bit of macro magic to say, QQ, go word forward, delete to the end of the word, go back, paste, colon, comma, go again. Cool. And I guess here we want to go like this, and we're chilling. And then we need to do zig case rules. So this, like this, we kind of swap the cases, throw some underscores in, and there, chilling. Okay, so this is the common section. And then we're going to have the simple glyph is going to be kind of the common section. Simple glyph is going to be common, glyph common, and then whatever the fuck we paste from here. And here we're gonna be like, oh, we can't define this. We can't define this as like a static struct because there are arrays in this thing. So we're gonna have to get a little bit crazy here. We're gonna have to get a little crazy, but that's okay. So I guess here we'll just store End PTS of contours. I guess we could still copy it this way, and we'll just kind of parse it a little differently. So this isn't going to be a packed struct anymore because we're going to have to do some like manual parsing for this thing. But yeah, this is going to be a end PTS of contours is going to be a slice of U16. So that's this. Instruction length is a U16. Instructions is a slice of U8s. Flags is a slice of U8s. And then X coordinates is uint 8 or uint 6 or int 16. How the fuck do I know? Where does the size of this thing come from? Like, or this must come from somewhere. This must be like a number that is defined in another table. The meanings associated with each bit in the byte are given in table 16 below. Okay, that's. Does this tell us why? Maybe flags tells us if these are 8-bit or 16-bit. Yes, here we go. So this is going to depend on the size of this thing. So how do we determine? I guess what are we going to do here? Maybe we say like X coordinates is going to be like. Oh, this is interesting. Maybe we're going to say like unknown like I guess we can just specify U16 and deal with it if it's not. I don't know. We'll see. And is that it? Nice. Okay. So here we'll just say fix me handle U8 or something. I don't know. Okay, so how are we gonna deal with this thing? So I guess we're gonna have like some sort of like get glyph at some sort of index, right? And this is gonna say like maybe get glyph common. Is gonna return a glyph common, I guess. And will you have issues with signs if you're defining this U16 for the R16s? Probably, yeah. Probably I16 is probably the better thing to put anyways. Because U8s will fit in I16s. Okay. So here we're gonna look at like self data at I guess we don't want IDX here. We probably want like start and end. Or start just kind of hand wavy. So then we can call like we're gonna look at TTF parser glyph get glyph common at this. Boom. Okay. I guess glyph start here is reasonable. And can we just write out? I guess we'll. Yeah. Let's do that. So can we just say glyph header is this? And can we just print that for now? Let's print that and see what we get. Glyph header. Fuck. Where is that complaining? 256. True, we just didn't do this, huh? It's a hard life sometimes. Stood mem bytes to value. We're trying to get a glyph table or glyph comment out of this thing. And then we need to fix the endianness of all the stuff inside, and then we return that thing. Fuck. 391. Use the undeclared identifier. Oh, because we still see glyph here. Fine. And we comment this out. Sure. He's mad because see, panic. We cannot look at index 2 through 3, 4 because it's larger than index 10. True, because I guess we need to do start plus here. We do need to go forwards, not backwards. And we have number of contours to x min, x max, y min, y max. These look kind of sane. right? We can say that min is less than max and min is less than max. The units here are kind of like hard to, we're like kind of unknown at this point, but it's probably fine. Does fixed endiness work with spans? No. So with spans, we actually clone them and then manually swap them. But it's kind of fine because nothing in these, like every time that we have these like fancy, these like slices, we have to do something special anyways. So I guess here we're gonna do like get glyph, or get glyph simple. Okay. And we can kind of go from the start to the end here. And we will show how we handle these. Here we construct ourselves a little generic parser thing that comes from self data at start to end. And then this thing, we can just ask it for like a value or an array. And then the array kind of fixes the endiness inside. So these are the things we are trying to get. Stood. So I guess we say const common is equal to generic parser read val of glyph common. Okay. Then we have end pts of contours is defined as an array of last points of each contour. N is the number of contours, which I think comes from the header. All right, so here we're looking for read array, and we are trying to get an array of U16s with some allocator because we need to copy. Here we say here is the allocator, and the number is going to come from common number of contours. Boom. Cool. Instruction length. What's next? Instruction length comes from the total number of bytes needed for instructions. Oh, so this is just a read val of U16. Chillin'. Then we get the instructions. So this is going to be a U8 array coming from instruction length. Chillin'. Flags is a array of flags. How do we know how many there are? How do we know how many there are? Each entry in the flags array is a byte in size, meaning associated with each bit in that byte area given below. How do I know how many there are? If set, the next byte specifies the number of additional times this set of flags is to be repeated. If set, this point is on the curve. If set, this is off the curve. But is there like a terminating bit? The field above? This is instruction length though, right? Am I stupid? Flag seems like totally unrelated. Unless it's in the like common header. No. Array of flags, so each flag here, one flag for each entry. Each contour has a flag, right? Each entry in the flags array is a byte in size. It could be, but then why wouldn't they write n here? Array of last points of each contour. N is the number of contours. Array entries are point indices. Okay. So I guess, do you have flags occupying more than one byte? I mean, it says here that they have more than one. Let's see. If I scroll down, does it say anything about the flags? No. Can we look up like a second spec here? I guess we could read this stuff too. Font must have at least 2 glyphs. The number of glyphs in the font is restricted by the head table. Includes specification of points. Blah, blah, blah. Table 14 describes the format glyph definitions. 0 positive number is a compound or is a simple glyph. If it's less than 0, it's a compound glyph. Minimum, maximum Y values, blah, blah, blah. Digitizing letter form. Can we look up like flags in here? Nope. The meanings associated with each bit in that byte are in table 16. Yeah, and then this does not seem interesting to me. So let's look at the Microsoft spec, because last time we did this, they were a little bit more helpful for us. The number of flag array elements. Note, in the glyph table, see below for details. Okay. Each element in the flags array is a single byte, each of which has multiple flag bits with distinct meanings as shown below. In logical terms, there is one flag byte element, one x coordinate, and one y coordinate for each point. The number of points is determined by the last entry in the end of points of contours array. Note, however, that the flag byte elements and the coordinate arrays use packed representations. In particular, if a logical sequence of flag elements or sequence of x, y coordinates is repeated, then the actual flag byte element or coordinate value can be given in a single entry, with special flags used to indicate this value is repeated for subsequent logical entries. The actual stored size of the flags or coordinate arrays must be determined by parsing the flags and array entries. Gross. But is it, can we kind of infer it based off of the size of the x coordinate and y coordinate? But I guess also the like x, you can kind of, the corresponding y, oh Jesus Christ. So each value of the x or y coordinates, they might be different sizes. So we kind of have to walk each flag byte and then parse out the x and y coordinates along with it. That's kind of fucked up. Okay, but we can probably like pre-allocate. Oh, this is so fucked. So we can pre-allocate our x and y. Hold on. Okay, so we know how many coordinates there are from the end points of contours element. So here, can we just do this for a second? We're kind of unreachable here, and can we just say like std debug print num contour points is gonna be it's like the endpoints of contours at end point of contours -1. Okay. And then can we like down here say like std debug assert that the glyph header dot, what was the glyph header thing that determines if we're compound or not? It's number of contours. So here we'll say that the number of contours has to be greater than or equal to 0, because that means it is a simple glyph. And then we say glyph TTF parser glyph get glyph simple from glyph start to glyph end. Okay. And then can we like just kind of discard that for now? Member function, he needs an allocator, I forgot. Okay, and then here he's met at 262 because number of contours needs to be in cast here. But we shouldn't be doing this unless we've already determined that this thing is positive, so we're chilling. This thing needs to return an error. Every time I tune in, this man is doing something interesting. Pretty soon, making my own operating system. One sec. We actually have a playlist, writing an operating system. Already been done. Already been done. Simple glyph. For fuck's sake. Incompatible types, u int 6, slice of u16, and comp time int. That's true. We did just write endpoint of contours again, like fucking idiots here. So here we need to write dot len. Okay, so now we have 10 contour points for the letter A. Does that make sense? 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus some like curve maybe for like an off. Yeah, there's that seems like maybe reasonable. Maybe it's not like insane. Um, and so why was I logging this? I wanted to start right because we wanted to start parsing the flags right now. Okay, so here we need to go like var I is equal to 0. Okay. I guess, well, okay, so we have like this like generic parser, and now that we're past the instruction segment, it's literally just like, let's read the flags one by one. Yeah, so we go like while true, probably. We do like generic parser. No, while I is less than the number of contours. So this goes like this. This is what we just calculated, right? While I is less than num contours, we like append to the flags variable, right? Now, what we don't know is how many flags elements there will actually be. But we know that like after we expand them, we should get enough, right? That's kind of the assumption here. So I think that what I want to do is I'll just like duplicate the flags. Fuck it. You know, they have like a repeat thing in there where they say, here are our flags, repeat that 5 times. Fuck it. We're just not going to do that. Right? So how does the repeat flag? If bit 3 is set, the next byte specifies the number of additional times the flag byte is to be repeated by the logic in the flags array. Okay. So repeat flag is equal to 0, so 8. Repeat flag. And I guess we just say generic parser read val of u8, right? We're gonna start by saying that the flag, we're gonna like start by making a flags thing. So this is gonna be u8 num contours times, right? And error defer alloc free flags, of course. Okay. Then here we're gonna be like flags at I is equal to this, right? Or I guess we'll say next. Oh no, I think we can say flags at I. Yeah, I guess we kind of unconditionally probably will defer I plus equals 1. This thing has to say that's a usize. And then we say if flags I and repeat flag is not equal to 0, we have some repeating to do. So we'll say the number of repetitions is going to be one more byte read from the stream, I think is what they said. Okay. And then we just go like for, I guess we'll say like here, const flag is equal to this. Okay. And then flags I is equal to flag. And then we can say for, I guess 0 to j. Sorry, 0 to num repetitions. Flags I is equal to flag. And we do I plus equals 1 here. So we just increment it that many times and we copy it in. Fuck it. I guess you could actually do like mem set flags from I plus 1 to I plus 1 plus num repetitions to flag, and then do I plus equals num repetitions like this. Probably. Something like that. Then I will get incremented again. And then at the end of this, we just want to check. I don't really know what to do now. I don't really know how to like validate this. I guess we will assume now that we can walk all of the x and y points, but maybe if here we'll do std debug print flags is any. I don't know. Something mad about an error union somewhere. Who the fuck is angry? Get glyph state 266. Fine. I'll retry if you want me to, little bitch. Okay, so we hit the unreachable. We did end up parsing a flags array, and we don't have any repetitions, I don't think, which means it's hard for us to kind of validate that code. But that's probably fine. It would maybe be nice to maybe represent. Maybe we want to do this, right? Equals like some sort of struct. Can we do like packed struct, which has a inner of a U8, and then on here we can do like is short y, right? We can start doing like stuff like this, and then we can do like can we like copy this stuff out? Jeez. Okay. Get this the fuck out of here. Get this the fuck out of here. This the fuck out of here. This. 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 Okay. This. Is from scratch here, meaning without free type? Yeah, we're just like literally opening a TTF and trying to draw something on the screen. Packed struct with 8 bool fields and then a bit cast. Yeah, I guess that's reasonable, huh? I guess that is reasonable. I do like that. So that's like literally just like here. Like this, and then like this. Okay, and then this is like this, and then down here this is like simple glyph flag here. We read a U8. Maybe we even read a simple glyph flag. We might not even have to get crazy here. And then we might be able to go like if flag dot repeat flag. Yeah, that might work actually. Then we don't have to do this either. Let's see if we get the same thing. He's mad about expected integer or vector found bool. Probably this is like on fixed endianness. We probably have to account for U8s somewhere. Yeah, I don't really know how to do this. Which case are we in? We're on like 215. Oh, so we're in here. Fuck. U1 instead of bool. Oh, that might do it. Yeah. Good thought. Good thought. And then repeat flag here needs to be nope, still unhappy. So it's that the like byte swap all fields thing is like, I guess we just say, I don't know, if This is like a hack, but we can say like if size of val is greater than bit size of val is greater than 8, we do this, otherwise we don't. And then that kind of fixes our problem, probably. Hack dodge packed bool struct. Okay. Cool. Cool. So now we can kind of like see if these things look sane. So hopefully reserved should always be false, I think. That's what it says here. We can kind of double check just to make sure we're not doing something stupid. So here we can just be like, flag dot reserve or reserved is equal to 0, which doesn't exist here. So we go here, I guess. Fuck. I guess it's assert that it's false. Maybe stores U8 some bitcast is needed. Oh yeah, I guess that does kind of make this a lot easier, huh? If we just don't kind of hack this shit and we pull it out as a U8 like this, and then we do like this. Sorry. Here. Yeah. I like that. So here we can do like const flag is a simple glyph flag bitcast of flag U8. Yeah. I agree. That's much nicer. Okay, cool. And then did we do that assert? Stood debug assert that flag dot reserved is equal to 0. Fuck. False. There we go. You shouldn't be byte swapping or anything with this one. Yeah, I agree. But sometimes, like, the code still gets run there, even though it does nothing. So it was just kind of like dodging. But yeah, it looks like that's working. So now I guess we go and we iterate the flags array. And here we need to get like a little crazy. So I think that here, for each flag, we parse an x coordinate. Right? So here we're going to allocate I16 of flag's length. Right? Because we know that there should be one x coordinate per flag. And for each flag, we're going to check if the flag has a x short vector. And if it does, we're going to read the next value as a U8, I think. Is that what they said? It's uint 8 or int 16. Yeah. So if it's short, we say x chords I is equal to generic parser read val of U8, right? Otherwise, we read it as an I16. And then we do the same thing for Y after. Okay. All of this gets done the same. Okay, that seems kind of reasonable. And then here we should see that we've like probably read the whole buffer. Right, so it'd be interesting to see like that the generic parser dot idx is equal to end minus start, right? That we have probably, we're hoping that we've read the whole array at this point. It'd be interesting to see if that happens. So no, instead, we are struggling to read the y coordinates, which is bad. That means that we fucked up somewhere. right? That's kind of like the only explanation. So this might be could be this. Num repetitions might be -1. Oh, but here we're supposed to have num contours. Okay. Yeah, so we are supposed to have the expected number of contours for x, y, and flags. So then the problem here would be that we are not reading the correct number of short and long here. That's kind of the only reasonable explanation. Okay, so let's think about this. It would be interesting to see what the index is. Right? If we're making it like almost the end and we're just like fucking up by 1. Or if we're like fucking up like early on in. So we're expecting to see 10 contours. We do make it to 8, so we're not that far off. It'd be interesting to look at the x values to see if they're correct. X and y coordinates can also be repeated. Oh, okay. So if the flag has, depending on how the x short vector flag is set, if x short vector flag is set, this bit describes the sign of the value, with 1 equaling positive and 0 negative. If x short vector is not set, and this bit is set, then the current x coordinate is the same as the previous x coordinate. If x short vector is not set and this bit is also not set, the current x coordinate is this. Okay, hold on. Let's look at this again. So if set, the corresponding x coordinate is 1 byte long. And the sign is determined by this. If it is not set, then the interpretation depends on this. Okay. Okay. So maybe we want to do something that's like like glyph parse variant. And we have how many states? We have short, positive, right? Short, negative. Long or repeat. These are the 4 options, and then we can probably set these as backed by U2. So this is going to be short and positive is sorry, x is same or positive. Actually, I guess we want to actually parse these from tuples. Yeah, so we'll say short and is same or positive. Short. Okay. Yep. So this is just if short if yeah, I guess we'll do it this way, fine. Return short pause, else return short neg, else if is same or positive short, we return repeat. Okay. Seems reasonable. So now we go like parse variant is equal to glyph parse variant for all bools. Flag x short vector. Flag is x same. Blah blah blah. We switch on the parse variant. And then we have like short pause is this. Short negative is this. Long is equal to this. And repeat is x chords idx is equal to x chords idx minus 1. Okay. And then we literally just do the same thing here for y. So here, just everything that says like x, y, y, y. There we go. This format is so weird. Yeah. You can say that again. We can't negate a U8, so we can just like as I16 like this. I think you don't have to cast to go from U8 to I16. It just kind of happens for free because all I16 can represent all U8 values. Okay. And oh, we hit the assert. Fuck. So this means that we kind of ran through all of this shit and we didn't make it to the end. So it'd be interesting to see what we're getting in here. So this is supposed to be the generic parser index. How many things have we read? And end my start. Like how many things were there? So we read 95 bytes out of 100, but there is supposed to be padding. There is supposed to be padding, so maybe this is reasonable. This could be fair. Okay, so now we should be able to actually just return this whole fucking shebang. Maybe? So we're at a dot here, we go here, we say yank to the end of the word, paste, go again. Hell yeah, dude. All right. So if we get the glyph here now, can we like std debug print the like x coordinates and y coordinates? Let's see if they look sane. Like maybe. You know, you never know. Who fucking knows? Who knows? I guess we could probably guess that this is wrong, right? Because if we're expecting these things to fall between x min and x max, we're definitely not, right? So it looks like we have hit a repeat here. Here, here, here. We're seeing a lot of repeats. I guess we could also kind of imagine. Hold on. It could be that these are in like fucked up units, right? So let's try to see. We have negative 10,000, followed by 1493, negative 1493. Okay. Can we graph these points? Maybe that's the easiest thing to do. Maybe that's the thing to do, because like the fact that these are doubled up is like seems kind of reasonable for the letter A, like to some extent. I think probably the next thing we probably want to do is graph this shit. And lucky for us, we spent happy hour today remembering how to compile Zig into some code that we can stick on in a WASM module and render stuff in HTML. So can we look at that? Desmos can take XY per line and plot it raw, by the way. Yeah, but fuck it. Fuck it, I don't mind. Okay, so how would we want to go about turning this into something that we can look at from WASM? I guess we want some sort of... Let's start by embedding the file. So can we say that the font data is the embed file of res... I guess we want like res hack regular TTF. Okay, we'll start there. Which means that these args disappear, this disappears, all this goes away. And we make their source res, and we move res hacklet regular. I guess we put this here. Okay. He's mad because 378 is mad about mirroring of data, so we can actually just put this here, and that kind of solves that problem. Did you take into account that the XY coordinates are relative to each other? No. No, I did not. Let's read that again. Contour point X coordinates. See below for details regarding the number of coordinate array elements. Coordinate for the first point is relative to 0, 0. Others are relative to the previous point. That's a really good point. That is a really good point. So we probably want to stay true. We don't want to like modify them in place here. So probably as we go through here, we're gonna go like for, can we do like chord iter? And we'll take this as like glyph chord iter maybe, and we'll take in the chords as a list of I16s, and we'll say that we have like some function next. We probably want our IDX in here as well, and we have maybe we even store the previous thing in here. Nah, we don't need to do that. Glyph chord iter. If self IDX is greater than or equal to chords len, we return null. Otherwise, we have to do something. So if self IDX is equal to 0, we return self chords at IDX. Here we unconditionally say self or defer self index plus equals 1. The flags are already about deltas and repeats, but I think that I misunderstood. I think that they're not about deltas here. None of these flags are about deltas. Oh, I guess here, if we have repeat then, we actually want to say that this is 0, huh? If this is the case. Okay. Then when we iterate the glyph, here we go, glyph iter, where the fuck this thing was, glyph chord iter. Else we return self chords at self index minus self chords. Oh, we have like some sort of accumulator, huh? Yeah. Yeah. Self acc plus equals self chords at IDX. And I guess here we do this. This thing starts at 0. And then we return self accumulator. That seems reasonable. So then we can go like const glyph x iter is equal to glyph chord iter given chords is simple glyph x coordinates. Boom, boom, boom. Y is y. And then we can go while true. X iter next. Or else break. Y iter next or else panic. Because they should be the same. And can we print then the coordinate? X, Y. Let's look at see if those seem at all reasonable. Fuck. Var, 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 var. Seems pretty fucked. Not gonna lie. Not gonna lie. Seems bad. Seems bad. Specifically, like, Y starting off at, like, negative, like, fucking a million trillion. Seems kind of bad, but we also haven't really looked too closely about what these things are supposed to look like. I would like to graph these things just to see. We might as well graph them. So let's try to get this thing runnable in the context of another application. So basically everything that happens in main here probably is going to go into like some sort of initializer. Probably. So this stuff is all about, this is like all of the actual interesting work here. So we create our parser and then we read the subtable. Yeah, okay. So we're gonna have pub function, or yeah, pub function read subtable given our TTF. And this is gonna return like whatever the fuck this thing is, a subtable format for C map table subtable format for, yeah. Okay. And that's just literally all of this. And he needs an allocator as well. Okay, and then we return this. And then everything else is pretty free. Okay. Maybe this stuff goes in there as well, to be honest. Well, for now, why the fuck not? And this is read subtable alloc TTF parser. Okay. So this thing probably can fail, presumably, because there are errors in here. Does this still run? It does, okay, and then now all of this stuff is like, get me the glyph chords for this one character, is all of this stuff. Glyph chords for car, and we're gonna take in our TTF parser, so TTF, and the subtable as the subtable, like, CMap table, subtable format 4, and he's gonna return, maybe we actually just return the glyph for car. And this gets like glyph table, simple glyph or something. Okay, and that's gonna be like all of this stuff essentially. And I guess we pass the car as well. Chillin', and I guess the allocator as well. Okay, which means that we can return this. And that means down here we can just say all of this is like get glyph for car, alloc, TTF parser, subtable, and car. Okay. Does that still run? We're not quite there because expected error union type found this, because this thing we didn't return an error. Boom, bang, boom, bang. All right, okay. So now I guess what we want to do is we want to compile this thing as a WebAssembly module and give some points to JavaScript. So we kind of have an example of this somewhere. Let's do this. Let's do a quick git add source main build index. Like we're just gonna kind of cache the current state. Because I don't want to lose it. And then what we can do is we can just start like hacking the shit out of the WASM stuff. So we can basically say const main is equal to import main. We're not getting to, we're being a little generous kind of. We're gonna have like an exported function in it, which is going to do something. He's going to probably like initialize some global variables. So we're gonna have like TTF is main TTF. Okay. And we're gonna have subtable. It's like main CMap. We have some exports to make here. TTF here and CMap table. And we need like subtable format 4 here, public. Fuck it. Okay, so then we have like CMap table, subtable format 4. On init, we're gonna do whatever the fuck we were doing down here. Boom, right? Which means that this has to be public and this has to be public, which it is. We have our WASM allocator here that we're going to be passing around. And we're going to be coming from main.font data. Just kidding. We're going to embed this here. Nice. Okay, chillin'. And then from here, we're gonna have some sort of like function that does the other half of things, right? So he's gonna be like, give me this char generator. Let's get glyph for car and then start iterating the points, I guess. Make iter for char. So we're gonna take in a character. And he is gonna return a like main glyph for glyph table, simple glyph. No, he's gonna return what is he gonna return? Probably like a glyph chords. Maybe our glyph chord iter will do both x and y together. Yeah, that makes more sense here. We kind of iterate them together. Okay, so this is like this, y is this. We return a couple I16s. And I think what is the easiest thing to do here to make it like usable from WebAssembly is to this is fine. This is fine. We'll say give me some glyph chord iter here. So like kind of all like this. We're gonna make a glyph chord iter with x chords and y chords like this. Okay. Then we return this. So we say const ret is equal to wasm allocator create a main glyph chord iterator. Boom, boom. Yep. And then we can just say next, given our iter next glyph chord. Yep. Yes, 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 yes. Okay, this is gonna be like this. I guess this is like or else return null here. Uh-huh. Same here. Catch return null, I guess, on both of these. Chillin'. Yes. Okay. So then here we say next glyph chord given this thing. Update, yeah. Advance glyph chord. And he is literally just gonna call like iter next. And he's gonna return if this thing return true, return false. Okay, so this will tell us if we're done or not. And then we can say like get glyph chord x, right? And this is going to be like given our iter, we can look at the glyph chord iter and return a float. And here we can turn like iter dot x accumulator. Nice, we got there. Okay, so this should expose everything we need to JavaScript land. Constret or varret. So the pointer is const, but the value that it points to is not const. So this is okay. This is okay. So I think this thing's pissed about a lot of stuff. So 32, we need to do like catch return, and really we should like error log here. Stood log error, failed to make TTF. Then we can say stood log error failed to extract subtable. Okay. What else is it pissed about? F32 found I16. True. Okay, he's mad about file descriptor stuff somewhere. That's kind of surprising. Why? Who uses a file descriptor anywhere in any of this stuff? Okay, this stuff is pissed about exports here. Yeah, where is this called from? Remaining reference file? I guess we can say void here, I guess is the easiest thing to do here. So this is coming from reference trace. Oh, from read subtable. Oh, because I have debug prints in here. So anywhere that says like stood debug print gets replaced with stood log error debug. I forgot. There we go. Nice, we got there. We got there. Okay, so now if I refresh this thing, what happens? He's mad because genline is not a function. So in our JavaScript land, we have a canvas that we've opened up that we can do whatever the fuck we want on. We just have to do the right thing. So what are our APIs here? We have init. And init, does it return something? No. So here we're supposed to call like module instance exports init to get our TTF, right? Then we're supposed to say module instance exports get something like glyph for character or something. Make iter for car. Make iter for char. Okay. So here we can do this. And I guess we can go like while module instance exports advance, whatever the fuck we called it, glyph chord. Yeah. With the iterator. We then say we have like x chords is equal to, this, and y chords is equal to this as well. Then we can do like x chords append push. Whatever the fuck we did here. Get module instance exports. Get glyph chord x. Nice. Nice. Okay, that feels pretty good. And then can we just like for now like console log x chords, y chords? Let's just see if we are getting the right values here. Unreachable executed. No. At fuck. So is this at an init? It is. So this must be coming in from here. Stood log debug hello. Damn, I was hoping that this would go better. So that's fine. We see hello here. What about down here? Still we see hello? Okay. What about in here? Hello. We still see the hello? So where is the unreachable happening? Hello. Am I stupid? Zig build? Oh, yeah, I am stupid. Okay, it's gone. We add it back. We're so back. So this is returning fine, which means that this must be returning fine, which is very confusing. Hello, hello. You're not passing in a char in JavaScript? That's true. But then shouldn't it... Oh, it's an index.js. My bad. So he's complaining at index.js 50. Ah, you're a good man. Good man. I see. I see. WASM. Make editor for car. So can we like stood log debug hello with this character. I see. Do I have to like cast this to it? Do I have to do like something like this? How do I like JavaScript? Can we just do like fucking know what an A is? There we go. Okay, so do these values look the same as what we were seeing before? I'm not really sure. I also don't know if it like knows what we're passing back here. So can we like stood log debug exec is this? Let's just make sure that we're like getting the same thing here. 1769, 107. You are making a good point that we're turning exec for yac. This looks similar. This 10795. Let's go back to main and double check. First of all, let's make sure that A is 41. It is indeed. And can we just go back to here and say X chords, Y chords here. Do the same thing that we did before where we kind of pass these here. Can this thing return like struct i16, i16? Okay. Point, 0, and 0.1. Okay, is that compile and run? So here we're getting like 769, negative 1067, nice, 1007, negative 7. These look right to me. 13789, 10244. Yeah, sick. Sick! We're so chilling. Okay, so now we should be able to like draw those things in JavaScript somehow. So let's actually move these up here, right? And we'll make it so that on draw we're going to like normalize these things to the width and height probably. Right? So here we're gonna like, you sound like that one guy from MK that pops up from corners randomly. I don't know what MK is. So here we're gonna have to like find the maximum. Is there like a function for that? Like JavaScript max value of array? Math dot max, and can I splat an array on him? Sure. Min is going to be min x is going to be math min x chords. Okay. Max x is max, and then we do the same thing for y. Okay, so then we're going to have to like basically lerp from min y to max y, given we're gonna have to do some sort of like mapping of points here. So we're gonna get like an x chord. Let I is equal to 0, I is less than x chords length, I plus plus. We're gonna look at like x chords I. And what are we gonna do here? What are we gonna do? We're gonna like take this thing, subtract min x. So if min x is like 1, we're gonna be like relative to this, okay? Then we're gonna say that this is like out of max x minus min x. And then we multiply all of this by width. Yep. Y is the same thing with just y's everywhere. And then we want to draw this into our canvas. So we want to like begin a path. And we want to make an arc like this. Boom, boom. And this is going to be X pause, Y pause, and hopefully that looks like does something. Hopefully we see 10 points. Hopefully. Boom. Fuck. Get line. Okay, why the fuck is he talking about get line anywhere? Control Shift R? Am I stupid? Oh, probably it's like in init somewhere. Oh, gen line. I'm just a dumbass. Okay. So this goes away, this goes away, this goes away, and let me just call on input. And X pause and Y pause I think aren't needed anymore either. Okay. So those are definitely some points on the screen that look like shit. Right? We can definitely not gain anything useful from this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, maybe? 8, 9, 10. Yeah, I mean, I don't know. Okay, this kind of lines up with my initial guess that this looks like shit. And I guess can we like confirm that we think these are on the right spot? So we have like 1, 2, 3, 4 at negative 1075y. 1, 2, 3, 4. Oh, but this goes from range negative 1074 to negative 9302. Yeah, it's like, this is just obviously fucked. One is quite nicely on the top left. Yeah, I saw that. Yeah, it's pretty clear this is fucking Garbo. Pretty clear. So now we can start trying to debug. Like, we were pretty sure that it was garbage already, but now we're like very sure it's garbage. Can we try doing like a different character? Also, hello. So we should be going to like index.js, change that A to like a B or something. And now he's just like fucked. So that's interesting. It may be interesting to try to run this thing for all characters here and see if we crash on B here as well. We do. Okay. So we're integer overflowing on X accumulator, but the B variable is parsing correctly. Okay. So I guess our assumption here should be that either the flags are wrong or the parsing of characters is wrong. So I think we can check here. If we do this, we should get a clue on if we crash or not. Okay, here we crash trying to parse the glyph, trying to memset flags. Interesting. So we are getting into cases where the flags array is the wrong size, which means that the best guess here is that the flags parsing is wrong. So let's think about this again. Could be if this is backwards, right? That's not, we didn't really check here. The ordering of packed struct bool endianness, right? Zig. Like, I assume that the first thing should be 0, but I'm not really sure. I guess we can check here by just in main being like simple, you know, we can be like const x is simple glyph table, simple glyph flag, bitcast from the value of 1, right? Let's just double check what we see here to make sure that we got the order of these flags right. So before we do anything here, we see that 0x1 sets on curve point, which hopefully is right. Bit 0 is on curve point, yeah. So then if we set, did we do the rest of these in the right order? X short, Y short, repeat, X is same, Y is same. Here he has double reserves, but in the Microsoft spec he had overlap simple, so whatever, we're chilling there. So this seems like probably correct. Okay. It could be that endpoint of contours is supposed to be -1 or +1. I assume +1 would make sense if it was inclusive, but ooh. Okay. So that makes it through all the glyphs, which is a interesting sign. If we then, that would also explain why we were off by 1 on a bunch of them. So can we like log the contours now and see if this makes sense here? Like if we try to log the contours for A, oh, these seem so much more fucking reasonable. Right here we have like -268 to 1092. Everything is in that range. And 1092 is at the fucking max. Okay, sick. So if we then zig build and refresh here, oh, tell me that's not a fucking B, dude. Right? You can kind of start seeing the shape here. That's pretty sick. +1 strikes again. Yeah, because it's that the end point of the contour was inclusive. Right? So it's not like it wasn't saying like this is 1 after the last point. It's like this is the last point. So that's pretty cool. Pretty cool. Now we can trust the bounds of this thing. Right? So here we can like kind of set the box based off of the min and max, probably. That be a B or it's a 3. Yeah, but it is a B. I guess what we can do actually is just kind of slide everything in a little bit. So in our JavaScript here, what we should do is we should set the min x to be like, we kind of want to like shift everything in a little bit, right? So like instead of putting everything up to the border, we just want to give like an extra offset to everything. So can we do like this? Maybe more. Really? Even more? Oh. Ah, my bad, my bad. I thought these were normalized already. They're not. They're not. So here we want to go like minus. I guess we just do this. And min x minus equals max x minus min x times 0.15 x border. Shut up. I know this is stupid, but it's fine. Max x plus equals, and then y border will give some extra y here. All right. I know we're doing a lot of stuff kind of manually, but there we go. There we go. I mean, ideally, maybe we should be using the numbers from the bounding box. But whatever, this is fine. This is fine. We'll kind of just keep moving from here. Okay, so what do we want to do if we want to like fill this stuff in? We need to look at the on point and off point flags here from somewhere. Right, so each point in this shit show has a on curve point flag. And I don't remember what this is, but it's related to Bezier curving for sure. So remember when we were talking about earlier, the fact that some points are off and some points are on, and you can like infer some points by being between two other points. So presumably somewhere they're gonna tell us about this stuff. This is about like placing things on the grid. I kind of want more about this. Okay, so curves that are parabolic in nature can be represented by a single quadratic curve. More complex curves can be represented by several connected curves. The tangent continuous joining of such components produces a quadratic spline. Such joining occurs when curves are connected in a manner such that the shared points have the same tangent. Right, sure. So like if I'm going P0, P2, P4, when I go from P2 to P4, the tangent is the same as when I'm going from P0 to P2. That makes sense. Connected quadratic curves have first degree continuity and tangent continuity. Each curve point is on the line connecting the two flanking control points. Such a curve is shown in figure 2. Sure. Now they go, it would be possible to specify the curve shown in figure 2 with one fewer point by removing point P2. Point P2 is not strictly needed to define the curve because its existence is implied and its location can be reconstructed from the data given by the other points. After renumbering the remaining points, we have the following: 0, 1, 2, 3. And how do we calculate this? I would assume that it's like halfway between P1 and P2, but I'm not positive. The on-curve points that define the glyph are shown in small black circles. The off-curve points are shown in the small open circles. In relatively simple glyphs like the letter C shown in figure 4, the sequence of points defining the glyph combine to form a closed shape. Okay, I don't really care about any of this. I want to know more about like the on and off point thing. So, like, what is going on with like 34, 35, 36, 37? These are all off point. So I'm missing how these things are supposed to be resolved. They're connected at their common point P2. So how is P2 defined though? Connected quadratic curves have first degree continuity, blah, blah, blah. Okay, I guess I understand this, right? This is defined by you interpolate from P1 to P0 to P1 and P1 to P2, and you draw a line between those and you interpolate that line. Now, what I don't understand. Oh, so I guess they're going P0, P1, P2 is one thing. P1, P2, P0, P1, P2 is one of the things, and P2, P3, P4 is another one. Okay, that makes sense. Now this gets a little tricky. So, I mean, my gut says it's just halfway. My gut says it's just halfway. So here we say like P1 or P2 is on point, line, and halfway between P1 and P2. Now, if we look at this again, we can say that there's a point halfway between 35 and 36 right here that is on the line, and between 36 and 37 right here that is on the line. Yeah, okay. Okay, I think that makes sense. That makes sense, I think. So maybe we try to render a Bezier curve here. Yeah, let's do that. So how are we going to do that? We're going to have some sort of like Bezier thing somewhere. Bezier curve. Sampler, we'll call it. And he's going to have, I guess we'll call this, here, we're going to have something that has 3 points. Quad Bezier curve sampler. Right? And this is going to be like 3 vec2s. Okay, something like this. Now, we're going to sample this thing at point T. I guess this doesn't have to be an array. Or a structure. So we're going to look at sample A, B, and C at time step T. Sample quadratic Bezier curve, okay? And we are going to feed this 3 points, and we're going to say, we basically want to take the line from A to B. We're going to lerp that. So we have to splat this, I think. We have to say like const t splat is equal to a vec2, which is splat from t. I'm pretty sure this is what we saw earlier today. So we interpolate both these lines and then interpolate the line between those. A, B, B, C, T splat. There we go. This should give us what we want. So can we... Have you checked out the video from Freya Holmes about Bezier curves? Yeah, it's pretty sick. It's a good video. Definitely a good video. Okay. So can we sample... How do we do this in a way that's exposable to our JavaScript? We want to maybe like make curve with AX AY, BX, BY, CX, CY for now. Maybe we even just sample this thing at time step t. Okay? And this is going to return, maybe we even get crazy and we just do it like this. Okay. Yes. That's good enough for now. I know it's a shitty API, but it is what it is. So we're going to have AX, AY, BX, BY, and vec2 CX, CY, and T. Okay, this is fine. We will live. Okay, so now we go into our index JavaScript, and I would like to sample some curves somehow. Don't know how I'm going to do that yet. Maybe for now, we have our little time slider that we added from somewhere. We have this thing, input t. So we're going to say input t is equal to this thing, and we say on input, we get some event, and we're gonna call, oops, arrow's in the wrong spot. We're gonna set t to this thing, which I think we have globally defined up here, yep. And we are going to have to call something. Let's just kind of scrap whatever we're doing here. We'll call this on input draw points or something, and then we'll call this on input Bezier. I guess we'll just call module instance exports sample curve x with AB. I don't know, we'll figure it out. We have like canvas width and canvas height somewhere, so can we do like width over 3, height over 3, width over 2. Yep, and then 2 times height over 3 or something. Then we're gonna do 2 times width over 3 and height over 3 again. So this should give us a curve to interpolate with our time value. X pause is equal to this. Okay, our Y pause is the same thing, but with a Y here. And then we want to render a ball. So here we just do this. Okay, and then we probably want to also clear the rectangle. Okay, so can we just make on input Bezier here and here? So I'm hoping to see some sort of Bezier curve that looks kind of reasonable in some way, shape, or form. Okay, so that's looking pretty good. We can kind of see some sort of Bezier curve following here, right? It's going from here to here and then like whoop, 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 whoop. So smooth. So we have some form of Bezier interpolation. And now what we want to do is what? I guess we want to figure out the Bezier points in our glyph based off of on point and off point curves. Right, so this glyph chord iterator, maybe it should just take in the glyph, to be honest. Right, like, maybe we just fucking store this thing raw. And then we can kind of store the Bezier points. Right, that's kind of what I'm feeling right now. So we have like an X accumulator, a Y accumulator. we immediately have to rip it to index 2. Kind of hand wavy. I don't know. Um, yeah, so we need to check if they're on or off. On or off. And what do we do if they're off? So if we have some sort of point definition, and we said that we convert 2 off glyph points to an on glyph point by just going halfway between them. That's what we said. I don't know if that's true, but maybe that's reasonable. So can we do something that's like, so we take the first 3 points, and I guess we say, do the off canvas points have to be, or off curve points have to be in sequence? There should always be 2 of them, right? Otherwise, you don't have things to interpolate between. Yes, I think there's always 2 or more. So we have some sort of like off to on curve, takes in off A and off B, right? And returns a new vec2. And this is just going to be like the average of A and B. So off A plus off B divided by 2, right? So we'll just write 2, 2 here. Okay. So then what? We're walking this thing. We're at like point 28, 29, and we see point 30. This is off curve. We go, oh, fuck. So 28 to 29, these are 2 on curve points, which means there's no like Béziering to be done. Right? Yeah, so if we see 2 on curve points, that's literally just a straight line. Okay. So what are our rules here? What are our rules here? We have A on B on straight line. We have A on, we have, I guess it's like on is straight line. On, off, anything, Bezier. Off, off, off. Off means like gets converted to any sequence of off, off gets converted into an on. And then on, off, on is a Bezier. That's kind of the rules, right? Could still draw Bezier for 2 on curves, result is still a line. But I don't know what like our third point would be. Right, we need like a third point to use as like off off goes to off on off. I think off off like means that we have to go back in time to find the last on point or something. It's like on off off gets turned into on off on with the off still kind of there in some way. So I guess like our glyph chord iterator is going to have to like somehow, I guess this is kind of going to be like a glyph segment iterator now. And he's gonna be like, maybe we just cache the last few points. So here, what happens from 29 to 32? We say 29, 30 plus implicit point, 30, then we go implicit point 31, implicit point. Right? I'm pretty sure that's the rule here. Yeah. So we're going to be looking at 30, 31, 32. And we're going to create our implicit points here. Yeah, and that's going to be the Bezier curve we're interpolating. Then for 32, 31, 32, 33, we have an implicit point here, and then 32 is our middle point. So I think we just always keep the last 3 points. Last points. Oh, maybe we have to look ahead. Maybe we have to look ahead. So we're gonna have some sort of like output from this thing, right? And it's like either gonna be like on or like line. Okay. Which is gonna have like A, B, right? Or Bezier, which is gonna have A, B, C. It's easiest 1, 2, 3. Go simple. Shut the fuck up. Okay, so we're gonna be like looking at 0, right? And we're gonna see like 1 immediately after, and we're gonna be like, oh, okay, so we have 2 points, we return a line. Okay, so here we say like, let's look at our glyph. This needs to be like this, and we're gonna be like x0 and y0. Maybe we need some sort of like point here, some sort of like helper thing, which is gonna say like on curve, and then position is a vec2, right? Then we can be like function get point at index. Okay. And he's gonna return like from the glyph segment iterator here. So he's gonna be like self dot glyph x coordinates at index. Position is equal to this. Okay, and we look at xy, and then on curve is equal to self glyph flags idx on curve point. Okay. On curve is equal to on curve. And pause is equal to pause. Would you just need the last on curve point in case of on it's the last point, in other cases it's the midpoint? I don't know. Talking about math is fucking hard. I'm just gonna keep going with wherever my brain goes now, and we'll see if we end up with answering your question. Okay, so let's get point at self IDX, right? This is A. And surely we need B, right? If they're both on point, if they're both online, we just return a line, right? That seems pretty fucking reasonable to me. A is A and B is B, right? Otherwise, we are part of a Bezier curve, right? Maybe not. I think if B is online, if B is on curve, we are always a straight line. I think. Because Maybe not. So what do we do if A is off curve? We are kind of resolving A to be halfway between A and B. Is that true in all cases? So we go 0 to 1, on curve, chilling, right? 1 to 2. So 1 is on curve. Then we're going to be drawing a Bezier from like 1, 2 to this like implicit point here. Then let's say that we have 2. 2 we're off curve all of a sudden. So what are we doing in this scenario? In this scenario, we have drawn the 1, 2 Bezier, and we're trying now to draw the 2, 3, 4 Bezier, I guess. Okay. Which makes sense. So we have like on curve points implicitly defined here, and then 3 as the Bezier control point. And then what happens on like the border here? So say we get all the way, we go all the way over here to 7, 7, 8, 9. So we're at point 7. We have to figure out what our equivalent on curve point would be. And then we do 7, 8, 9. Yeah, and then 8 is off curve. And I guess if B is on curve. Hold on. I'm not really sure what happens here. So we go 7, 8, 9. We kind of like 9 is kind of like the fixed endpoint. Right? So like 9 is like here. And we have kind of like 8 is our control point. And then we have like 7's over here. And so we kind of have like this implicit point here that draws like this Bezier curve, right? Then is 9 involved in a Bezier curve? No. Afterwards. Then it's just like 9 to 10 is like a straight line. Which is kind of interesting. So there's no Bezier curve that where like 9 is a control point. So 9 can't, right, because if 9's on curve, it can't be a control point. So if B is on curve, means not Bezier. So B on curve means that either we have to skip or draw a line. So I think in this case, we literally just skip. Right? Because here we have like 8 off curve, 9 on curve. We've already drawn the Bezier for 7, 8, 9. So we literally just go 1 forwards. We say, okay, now draw the 9 to 10 line. Fuck it. Okay, so that's kind of what I'm thinking now. Get point doesn't do the accumulation. It might get fucked up against less times than the refactor. Yeah, I understand. We'll get there. Okay. So now what? Now we just have the case where we're trying to draw a Bezier curve. So now we just have to, we know that there's going to be a C. And we need to resolve each of these points. So if A is off curve, so here we know B is guaranteed off curve. Or, yeah, at this point. Okay? That's for sure. And so now we just need to resolve A and C. So we're going to say like A on is like resolve point with AB. And C on is going to be resolve point of BC. Oh, yeah, that makes sense. And then we just return here that we're doing a Bezier of... Oh, yeah, that feels right. A is equal to A on, B is equal to B, and C is equal to C on. Okay. Now we just need to figure out how to resolve a point. And probably we just say, function resolve point of a point b point, and we return back a vec2. We say I think that we always make it this way. So here we're going to say that the this is the off curve point, off curve, and maybe off. So if maybe off on curve, return that point directly. Otherwise, we return the position interpolated with this. Yeah. We interpolate this. So over vec2, 2, 2. Oh yeah, that feels pretty good, man. Feels pretty good. Okay, so you guys were right that we do have to handle the like accumulator stuff. Also, this vec2 probably is supposed to be I16, huh? Probably. Which is a little confusing. I'm just gonna cast to, probably we'll just cast to floats for now because I don't know what to do. So we'll figure that out later. Yeah, okay, so we do need to accumulate. So how do we do that? I guess we look at the A value and we just do self x accumulator plus equals A pause 0 and Y accumulator is incremented by 1. I'm gonna change the vec2 here, I think. I vec2 is equal to vector 2 I16 or something. Okay. Oopsies. Fuck. And then the hard part here is resolving the point. This is actually also fine. There's actually no problems here. The only problem is going to be on Bezier stuff, but we don't have to worry about that yet. Okay. So we were talking about like this stuff, and I think that's fine. And then here we need to get point here. We need to like add. So here we need to go like for self.idx to idx. We do something that's like, we like accumulate some shit, I guess. Right? We say like, we do like this. Yeah, it's like something like this, right? Okay. Maybe. And then that means that this stuff has to just be like an equals. We just steal A. We say, this is our new accumulator. Oof, that's really rough. That's pretty damn rough. Okay. We can try this. So we return. We return this is equal to 0, right? And I guess that means that we don't need an init thing. You can always do 0 to idx instead of having to do self x y act, but it's going to be slower. I think it's harder for me to think about as well. Maybe. I'm not really sure. We'll see. And okay, so now surely this isn't gonna compile in some way. So we have to like glyph segment iter here, and we're gonna pass in the glyph is our simple glyph. And let's just see what we get out of this thing. Let's see, like, let's just see if the letter A seems at all reasonable in any way, shape, or form. Fuck! This one. Yeah, this does need to be a type. That's a really good point. Fucking whine this guy. And then 478, he's pissed about something. True, we do want to just, like, take the positions and all this thing stuff. All right, so for A, we get a lot of lines. We fuck up out of bounds indexing here, which is interesting. At 516, we say get points idx plus 1. So true, we do want to say, we do just not check, huh? So I guess we'll say, if self idx is greater than or equal to, I don't know, self simp glyph x coordinates len minus 1, right? Because we always have to go at least one forward. We're always going to look at B. We kind of do this. Okay, and that looks, you know, somewhat reasonable for the letter A, I'm not going to lie. A bunch of straight lines, and then can we look at, like, what happens if we try to type, you know, B and C as well? Really appreciate the content. I'm working on my first game right now. Hell yeah, dude. Hell yeah. Thanks for the bits. Much appreciated. So B, we should see line, Bezier, 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 line, line, Bezier, Bezier, Bezier. That's not crazy, right? That's not crazy. We are crashing here, which is interesting. So here, when we're trying to resolve point C, we have an issue. Which is kind of interesting. So we're going out of bounds, which means that B was off point. It means that the last point was off curve. Right? Which is pretty strange. It seems like the last point can't be off curve. I guess it could be off curve if the last... I don't see why it would be, but I guess... we'll just kind of... We'll just do this. Because I don't really know what to do there yet. Okay. So now can we try to render these things? So if we try to build our WASM shit, it's gonna get mad because glyph chord iter is now glyph segment iter. Glyph segment iter, okay. And with the way that the WASM stuff has to work, we have to like stash the output. So can we get a little tricky here and say like, we'll call this like stashed glyph segment iter. And we'll call this the, we'll stash the last output of this thing, which is this. I don't know. So this can make a stashed glyph segment iter, right? This can make one of these, and here we like create a glyph segment iter. I guess here we create one of like these, stash glyph segment iterator. Then we have like inner is equal to this. Ret dot last is equal to null. Okay. Then when we advance this thing, we call like this on the stashed iterator, and we say iter inner next, and I guess here we just say lat, iter last is equal to this, right? And then if iter dot last, or I guess we return iter dot last is not equal to null, right? Cool. Then what do we do? Does it always terminate at 0 in Platinum curve? Maybe. I don't know. Who knows? Okay, so then we're gonna like get the type. We're gonna call this advanced glyph segment, I guess. Somewhere you made a vec2 with XX. Don't remember where exactly. That's so fucking classic. Was it this? ivec2 too? That would make sense. ivec2 xy, abc, ab. This might be intentional, but you might have noticed it somewhere else. In which case, we'll get fucked later, I guess. We're using this anywhere? No. This is gone. Fuck this shit. Okay. So I guess we want to, like, request the glyph. Can we get, like, get glyph chord AX? Which is going to return iter last A. I guess we have to, like, switch. How do we want to do this? We want to, like, is glyph segment Bezier. So here we'll say this takes in our stashed glyph chord, and we say switch iter dot last. If it's Bezier, we return true. Else we return false. It's something X repeated. Well, I'll find it. Yeah, we'll see. It'll come up. Okay. Is the segment Bezier? If so, then we can say, we can get like pub export function get glyph segment AX. Gross. But like, what are we gonna do here? I guess, yeah, it's fine. X, we'll call this line, I guess. Return line dot A0. Oh god. What are we doing to ourselves, man? What are we doing to ourselves? B C unreachable. Gross, but like, I guess this is what you do if we're trying to expose APIs. Why? 111. Woo! And then we have sample curve here. Okay. That's fucking stupid. Okay. So now what? We try to use this thing. Does this compile? Of course it doesn't. So here we just need glyph is simple glyph. Okay. And then in index JavaScript, we will start by getting all of our line segments. CXCY uses B still. Fuck. Thank you. Good eye. Dude, I'm so shit at writing code. Holy shit. Segments. I guess we'll call this lines and Béziers. I guess that's probably the way. No. I actually don't know. I don't know. Let's for now stash everything as a line. Okay. Just for now. And we're gonna call like something like we initialize our thing. We then want to make iter for car, which do we have that function still? Make iter for car, chillin. We have advanced glyph segment here now. And I guess now we'll just be like if is glyph segment Bezier. Yeah. We will, I guess unconditionally we can get the first section. Unconditionally we can call get glyph segment AX. Okay. You know, I'm kind of starting to regret WASMing this. I'm not gonna lie, guys. This is ridiculous. AY. Okay. And then if it's Bezier, I'm gonna do something that's like let bx is equal to 0, by is equal to 0, and then here we will set bx and by to actual b if it's not Bezier. But if it is Bezier, we lie and we use c. There we go. Okay. Then we can say lines a push AB. AX, AY, BX, BY. And I don't know what that's going to do, but we'll call function draw lines, I guess. Okay, so we're going to clear the rect. We're going to go for let const line of lines. Debug console log line. Let's just start there because surely everything's fucked, right? We don't like surely. Yeah, x chords is not defined. Sure. Okay. So then can we call draw lines like this? Okay, wait, that's good. So we do have our lines, and then can we like actually draw them? So I guess we begin a path and we say move to line 0, 0, line 0, 1, and then we do line to the second one, and then we stroke, maybe? Okay, that's the worst thing ever. Probably because of somebody was claiming that we did XX somewhere, so that would probably do it. This is 0, 1. Here we have XY, XY, XX. Nice. There it is. Does that look better? That's something. Definitely not better. Can we do like the letter A first? That we're not doing any. We don't have to worry about like any Bezier stuff. Where do we do the letter A? Or oh, here we use the hex code. Okay. That looks shit. Is it something to do with the accumulating? I thought that we fixed it because we handled in the accumulator. We assign them here based off the value of A, and then on A, we like use the existing accumulator to get what we need to get, but maybe not. Okay, can we like log the points? So let's say in WASM, can we do like stood log debug line is any from iter last. Let's just like, dude, these things look sane in any way, shape, or form. A is always 0, 0. B does seem to be advancing, but kind of shittily. Okay, so that's a clue. Okay. So that means this is fucked up. So here we go. Give me the x coordinate, add it to the accumulator. Return that shit. I think there's a +1 that's got to be done there. Doesn't look right, huh? Looking at some code which always draws a Bezier seems simple. That we had an input midpoint between and then just draw. Yeah, that makes sense. That does make sense. That would work. I agree. Okay, so what the fuck have we done wrong here? Oh. Point IDX, I don't know. Fuck it. Okay, so does this look right? The points of A might be reasonable. The points of B are not reasonable because B should always be the next A, right? If we're drawing lines between points, then like this should equal this. Right? So we've done something wrong there. We can prove this by drawing in index.js. Can we draw A as a point? So we can go like line 0, 0 and line 0, 1. We forgot to do like our interpolation as well, which probably isn't helping us, to be honest. Fuck. Hold on. Can we just make a bigger canvas? Hold on. What's our maximum here? It's like 1500. Maybe this could be an upside down A. Right? That doesn't seem crazy. Now the lines between those points are fucked, but maybe the object itself is fine. So let's try to figure out why the fuck B is broken. What is wrong with point B here? So here we say, give me the point x plus 1. Oh. We need to do this at the end. Okay. That's starting to look like something, right? We do see line here, line here, line here. That's looking a lot like an A. Now, it's confusing that we're missing what seems to be the last line in each one, and then this is like accidentally skipping between contours, which is kind of interesting as well. I would not have expected that. I guess we're also like not really handling contours in any way, right? There's supposed to be two contours in a glyph. Where is the second contour going? Endpoints of contours. We're just not using this shit. Okay, so we can fix that. That seems pretty easy to fix. We say like, endpoints of contours. So we'll say like contour IDX is 0, right? We'll say if endpoint of contours at the contour IDX is equal self IDX, we increment this by 1 and just fucking skip this line. There's no work to be done. That's not good. Oh, because we still have to do the accumulator stuff. Okay, so now we don't have this line here, which is good, but we're still missing the last line of each one of these things. Which is kind of interesting. Kind of interesting. Also, why the fuck is it upside down? We're not gonna worry about it. We're not gonna worry about it. Okay. Yeah, why are we missing the last point? Well, because it's this. No, because it shouldn't be here, because we should be in this scenario where A is on curve and B is on curve. Maybe step one further. Oh, wait, hold on. No way that that's it, right? No. Okay, so we go. Let's look at what we have here. We have lines 494. What's weird is this is happening for both contours. Right? That's kind of strange. I would have expected that we would only have an issue on the last contour. But we're missing the fucking point for both of them. So can we log? So it's this. Right, because this is not exclusive. Okay, wait, it's something here. It's like, if this is true, we need to increment the contour IDX, but keep going? No, because no. If we are seeing the beginning of the line on the boundary, there's nothing to do. Wait, that makes sense. That makes sense. But it is also removing the point that was drawn there, which is kind of reasonable. Pretty reasonable. So we are starting this is, these 2 points are here. Okay, so we start kind of like here, maybe. Then we go to this one. Then we go all the way down to here. Then we go here. Then what is 877, 389? Maybe I'm wrong. So the maximum value is 1493. So that's these guys up at the top. 1493, there should be 3 of them. Or 4 of them. No. There are not. Oh, 0. 0 is the top. Fuck. 1493 is the bottom. So we are starting down here. So we go here, here. Then up to the right, 11960. So that's here. Here. This is this point. This is this point. This is this point. This is this point. Okay. And then we go straight to 829,551. And really, we're missing the line that should go back to here. So maybe there's an implicit wraparound. There might be an implicit wraparound, which would explain how the last element can be off curve. I see. Yeah, so here we need to do implicit wraparound. So here we basically want to take the start contour point and keep that, write that down somewhere. Oh, okay. So I guess we say first contour point is equal to like self get point self idx plus 1 or something here, right? That's kind of what I'm thinking. Then on init, we need to set that thing. Okay, okay. How do you know if the inner shape is cut out? We'll get there at some point. Probably not today because it's already 4:30, but we will get there. Okay, so this is gonna be the glyph here. Var ret is equal to glyph segment iter with glyph is equal to glyph, and then we need to find like first contour point, and we'll just set this to undefined, and we'll say ew, bad API. And then we just say ret first contour point is equal to this, return ret. And okay, so now in WASM, instead of constructing this thing however the fuck we were constructing it, we need to do ret is equal to ret.inner, sorry, is equal to this thing initialized with the glyph. Okay, okay. And then he's mad because get point is like not right. Because first contour point has to be a, I guess here we're just like, fuck it. Get point, expected type this found point. Am I fucking high? Oh yeah. Okay, and then here now we have that point, and we should say that we need to return a line between those 2 points. So, we don't know how to handle the fact that it's off curve yet, so I guess we'll have to factor some stuff out, but for now I can do this. Fix me factor out 3.2 resolved point logic. But for now, we'll just assume that it's a line. And we'll go straight from A is equal to A, and B is equal to self first contour point. Oh, baby. Okay. So we're still fucking up the last one here. But that's looking pretty good. Okay, can we draw B? How's the B looking? Okay, so we're missing the last line of the last contour, and then it's hard to see the stuff at 0, 0, but I'm pretty sure there is in fact a line there. So this is doing like a lot, almost the right thing. But we're just missing this last line here. Which kind of indicates that this needs to be not -1. Okay, which is now crashying. But I think that this will work now for the letter A. I believe A will work as expected. Fuck, it will not. Okay, I was wrong. Unreachable executed. I thought that would do it. So there's something about... yeah, I'm pretty surprised there. But okay, we're missing the last one, but it's fine. I think we call it there. I think that this is pretty fucking good progress. Right? Like, this is pretty slick. We have a lot of improvements to make, but, you know, we're seeing something. 4, 4. There's the letter D. We're missing the last line again. E. Again, we're missing some lines. Oh, wait, maybe those are drawn, but it's just kind of hard to see. We're missing this one, though. 45, 46, F, upside down. Yeah, okay. We've definitely got something. It's obviously less than perfect, but upside down symbol wax the polarity. Yeah, I know. I understand now. It's that 0, 0 is supposed to be on the bottom. What does O look like? Hold on, man, ASCII. O is 40F. That's not good. There's a bug somewhere. It looks like we're misattributing one of the lines, but you know, we're getting somewhere. I'm gonna call it there, yeah. Good progress. So we have extracted Bezier curves from the letters. We are not drawing them yet. We are kind of treating them like straight lines. But we have also resolved like on curve and off curve points, which is pretty huge. C.carcode at 0 for future, by the way. Oh, thank God. Damn it. Why didn't you say that like fucking an hour ago? What about the letter I, which is not L? We can look. You guys, I was trying to do my wrap up, but now you guys have got me. Do you want uppercase I or lowercase I? I'm kind of curious about lowercase I as well. So we can try both. There's 69 and 49. So 49 is an uppercase I, which is as you would expect. And 69 is what the fuck? Oh, this is the dot here. So we have like the I component here with a little thing because it's monospace font, and then the dot up here. Lowercase separate islands. Yeah, but it's not using compound glyphs, so it's totally fine. Right? We have two shapes which happen to do the same. Like the logic to draw the I is the same as to draw the O. Right? It's like two contours. Because of the fact that it's not a compound glyph. Thank God we don't have to handle those yet. Okay, fuck it. Thank you for watching, guys. We made a lot of progress. Happy with that progress today. We managed to like pull out the glyph. We managed to resolve on curve, off curve points. We did like a little bit of Bezier rendering, but we didn't actually hook it up. But I'm pretty sure that we're like pretty close to that working. So really, we just have to like fix the Bezier curve. We need to make it so like the renderer knows how to deal with that. Probably tomorrow we'll start moving into pushing all of the rendering into Zigland anyways, because I think that this like point stuff. What I wanted to do is I wanted to like show interpolation of Bezier curves, but I just think it's not worth it. I think it's not worth it. So we'll probably just ditch this HTML stuff tomorrow and just start rendering into like a image buffer. But we'll do the Bezier stuff tomorrow. We should start working on masking stuff, which should be pretty straightforward and fun. So swing back by tomorrow if you want to see that. If you're new here, there's a YouTube link in the Twitch description where you can check out all of our previous work. So we're working on a font rendering right now, but we've also worked on like an image editor, a debugger, QR code decoder, like a operating system. I don't know, there's stuff in there if you want to check it out. Does this include kerning? Bro, do you think I know what kerning is yet? You are expecting way too much competence from me. Code for this will end up on the GitHub under the font rendering repo, and then eventually it should fold back into the image editor repo. Sorry, no, you're good. I'm not saying like don't apologize. What else? YouTube. Swing by on Twitch if you're online between 12:30 and 4. Pacific time. Sorry, brains fried, frazzled, whatever. Let's just say goodbye, YouTubers, and Twitch. Let's find someone to raid.